Good afternoon, my YouTube students. And in this video, what we're going to do is we are going to take house prices and use those to demonstrate the measure of variability. And so the way we're going to do that is the first thing that we're going to do is we are going to import the libraries in Python that we're going to need to use to accomplish this. So the first thing we're going to do is we're going to import NumPy as NP, which is your numeric library, and we're going to import matplotlib.pyplot as PLT, which is your visualization library. Then what we're going to do is we're going to set the seed. So we set the seed with np.random.seed. So basically what that does is that initializes your program. So every time you run the program, then it will initialize with the same figures. So now we're going to create a data set of house prices with a normal distribution. So normal prices equals np.random.normal. Loc is 300,000, that's your mean. Scale is standard deviation, that's 50,000. And size is 100, so that's 100 samples. So we're going to add some high prices to create outliers. High prices equals np.random.normal. And loc looks like 1,000,000 to me, and that's your mean. Scale is 100,000, that's your standard deviation, and size is 5. So you're only going to have 5 high-priced houses. So you're going to combine the normal prices with the high prices. So house prices equals NP, concatenate normal prices, house prices, high prices. So now we're going to calculate the range, the variance, and the standard deviation. So price range equals np.ptp house prices. Price variance equals np.var house prices. Price stdev equals np.std house prices. So you actually calculate the range by taking the highest range and the highest value and subtracting the lowest value from it, and that's going to give you your range. The variance is a formula that is derived by figuring out how far away the data is from the mean. And the standard deviation is the square root of the variance. So now what we're going to do is we're going to print the calculated values. So you're going to print the range of the house prices, the variance of the house prices, and the standard deviation of the house prices. And then after you've done that, you're going to, so your range is 814,858.68. Your variance is 2751,051,991.05, and your standard deviation is 144,052.25. So that variance, it looks like there's a big problem with the variance because I don't think you had any house prices that big. So let's see what it says. That's what it says. Price variance equals NPVAR house prices. But it doesn't look right to me because the variance, if you come down here to the variance, it's really big. I mean, it's like hundreds, thousands, millions, billions. It's like 20 billion. So there's definitely a problem there because your range of your house prices is 814,858. So your variance shouldn't be any bigger than that. So let's just look and see. Price variance equals NPVAR house prices. So it looks like there's a problem there, doesn't it? And but we'll just go ahead and continue on with the code review because that's what the program says, even though it doesn't look right to me. The standard deviation doesn't look too bad, but I think the variance, if you've got a variance of 20 billion, that's quite a bit. And then so we printed the range of the house prices, the variance of the house prices, and the standard deviation. So after we printed it off, we plot a histogram. And so we're going to plot two histograms. One's a histogram to visualize the distribution. And then we're also going to plot the house prices. So the histogram is going to be house prices, bins equals 20, color equals purple, edge color equals black, alpha equals 0.7. The X label is your price, and the Y label is your frequency. The title is Histogram of House Prices with Outliers. So now we're going to also plot the house prices. And so that's going to be, it's going to be a box plot. And the X label is your price. And the title is your box plot. And the grid is true. So here we've already talked about the range, the variance, and the standard deviation. And I'm not really happy about the range. I'm not happy about the variance. I don't see how 20 billion can be a variance, but that's just what it says. And so now we do a histogram of the house prices. So you can see we've got price in dollars, and then so it starts you out at like maybe 200,000, and it takes you all the way to $1 million. So most of the house prices are going to be 200,000 to 400,000, with the mean of that around 300,000. But you've got some outliers there that are around $1 million. And so the outlier is going to affect the median. We've also made a box plot of the house prices. So you can see the box plot is going to be anywhere from 200,000 to $1 million. So the median is going to be around 300,000. The first quartile is going to be around 275,000. The second quartile or the third quartile is going to be 300,000, and the third quartile is that 75% is going to be about 350,000, 400,000, and then so the left whisker is going to be 200,000, and the right whisker is going to be 400,000, and then the dots are your outliers. So that's it. That covers the house prices to give you an idea of how to calculate the range, the variation, and the standard deviation. But I think the standard deviation is more accurate than the variance, because saying a variance of 20 million, I'm not so sure about that. But that's what the program says. I mean, we were just using the formula from the program, from the library in NumPy. So I'm going to go ahead and conclude this video because we finished talking about the house prices. And we've looked at two charts, one being a histogram to show you the prices, and then another one being a box plot to show you the prices. So the next video is going to be another statistical topic as well. So thank you for watching this video.